Okay, folks, I'm going to try something a little different on how I'm working this out and presenting it to you. This is going to be for the activity that we just did today. And I was asked question number 4. And so the first thing I need to do is talk about the graph here, and then I can switch over to a picture I can draw on and do work on. And so the first thing you need to take note of is the question. Let me go ahead and go to the question real quick so I can read it to you and we can have that to talk about. Is question number 4 is using the graph and the specific heat of liquid water, which is this number right here, 4.184 joules over grams degrees Celsius. Calculate the mass of water in the beaker. Okay, so we have a beaker of water. We're heating that water, and we're going to look at the liquid water portion because we've been given a specific heat for liquid water portion. So we better do that portion. Notice that the liquid water portion corresponds to this right here, which goes from 0 degrees Celsius to 100 degrees Celsius. That means that we're looking at this heating of liquid water from 0 degrees Celsius to 100 degrees Celsius, and we're going to use that specific heat to determine this value. And so that's, by the way, how you look at the molecules, what they would look like during that time, at least what it would be modeled as. If you look down here, you see that there are numbers in heat. We actually need to figure out what those numbers would be. And so if I remember correctly, and if I look correctly, these numbers would be something like 40 to, well, that's 120. That would be 100 there. And so this would be like a little bit less than 90. And so if I'm very, very careful, it would be something along the lines of 42 kilojoules. But look really, really closely because there's like one off there. And then that right there is 110. And if I subdivide this very carefully, this would be not quite 100 there. And so we're probably talking about like an 85-ish there, something like that. So yeah, something like 42. And you can actually do it a bit more careful if you access the text-only version. Probably a little easier to get those numbers out. Okay, so I get my number for the heat that caused the temperature to go from 0 to 100 degrees Celsius. I'm going to need to look at a change in temperature. So what is a change? Change means a final, where it stopped, minus an initial, where it started. And so my change in temperature is really easy for the liquid water because it's 100 minus 0, which would make it a change in temperature of 100 degrees Celsius. So remember these numbers and write them down. You have a 100 degrees Celsius change in temperature that you had to use, let's say, 42,000 joules to do, or 42 kilojoules. Those mean the same thing. Okay, so let's go ahead and go to our problem. Remember, again, that we just discussed and had a 100 degrees Celsius change in temperature, right? And we had a 42,000 joules of energy were provided to do that. And so that would be your energy right there. Okay, notice these numbers here have units that correspond to the units that are up here in our constant. And this is how I would always do things. So at the end of this, I want grams, don't I? Mass of water, which is grams. And so remember, a 4.184 joules, this would be divided by 1 gram, 1 degree Celsius, right? That was what that means. If you don't have any numbers, that means that it's 1, because anything multiplied or divided by 1 is the same thing. And so I go ahead and I'm going to flip this because I want grams on top. And I'll put 1 degree Celsius, but I don't really need to. This right here is the railroad tracks. Anything up here is multiplied. Anything divided is going to be down here. If you divide by it, it'll be below. And so I'll put the 4.184, and that will be joules, because that's my units that are on top. I flipped this number so the units on bottom are on top. The units that are on top are on the bottom. Notice the 4.184 is with joules. It needs to stay with joules. The numbers on bottom were 1. And so I put 1 up here. Okay, so now I'm going to get rid of units until I get what I want out of this. And that's just dimensional analysis. And so what do I know about this situation that I can use? Well, I know we heated this 100 degrees Celsius. And so I want to get rid of degrees Celsius, so it goes in the bottom here, degrees Celsius, and this is 100. Keep in mind that anytime you multiply a degree Celsius, this always has to be a change in temperature, because you would not be able to multiply a degree Celsius typically if it was not a change, which is a relative value. Absolute values don't work well when you try to multiply them in equations. Okay, so the next thing we're going to do is we have canceled degrees Celsius now. There we go. And so the next thing we do is, wait, I want grams. Okay, so that isn't going to be fathered. I have joules here, though. I need to get rid of joules. I have a number here that's joules. That's the amount of heat, right? And so I'm going to have to multiply this number of joules. I'm using the American version of the comma and periods, by the way. The European version is backwards. Joules cancels joules. And so I usually don't multiply or doing anything until I go ahead and simplify. For example, I'm dividing by 100 here, and I'm multiplying by 42,000 here. And so 2 of these zeros can be canceled out like so, leaving me with 420 divided by 4.184, which ultimately ends up like 100. So this is something like 100 grams, okay? And let me go ahead and I'll actually just probably use my answer key. You guys want to use your calculator to do the math, but my calculator is across the room. So I'm going to cheat a little bit. I'm going to use my 42,000 joules there, divided by that 420 that was remaining, divide by 4.184, and you get about 100 grams. Close enough. And that's that. Please let me know if this works out okay, if you guys can understand this all right, or if you just have more questions, period, okay? I can do this different ways. I could give you guys different workouts, etc. Let me know if this works out for you, or if you'd like some other way of doing this. Take care now.